where the state connector and FTSO come from. Nothing in Ethereum could do anything like that. You just couldn't design that. It's not feasible. So they have this ability to use the base layer for security and to put everything that they need in the protocols, because that's where the value is. The value is in the protocol built into the network layer of the blockchain. That means that anybody can interact with it. It means any Dapp can interact with it without permissions. There's no permission ever needed to access any of these protocols. Anyone could build a bridge. Anyone could do anything. And that's what drives the network effects in the future.
This is the product that Flare Network produces. And it's a very difficult product to get. And the Oracle problems since the days of Vitalik in 2016 have really not been solved. Chainlink has not solved it. So there's probabilistic data and deterministic. Flare built 2 core protocols into the network to solve this specifically and use the network security, because there's nothing more secure than a blockchain. And it runs Avalanche's Snowman++, which is a super high efficient decentralized consensus.
Again, it's decentralized. It it operates with a large number of participants. It's embedded into the network, so it's part of the network. And this is where it gets its security from. So other Oracle services are, generally, broadly, they don't derive their security from being participants in a blockchain with value at risk. This is a really important factor. Like, essentially, they sit on top of a blockchain, and broadly, that is why they have had to have a centralized model, right? So you've had to basically trust oracles, and the reason you've had to trust oracles is because it's been too hard to engineer essentially a system where there's an economic reason for an oracle not to lie. This is why we've built Flare. We've built Flare to basically be a base layer for data, secured by the layer itself. And I think I said earlier that the most important thing about the state connector is it's not secured by proof of stake. So even though to get into the state connector, one will eventually have to put up some stake as being part of a validator, but the security properties of the system does not rely on that.
I'm walking the bull, go, out for the. Out for the
3, 2, 1, 0.
Absolutely the first main layer 1 that acts as a data provider network. The core aspect is how you secure that oracle. Key difference between us and other oracles is that our oracle is secured at the blockchain layer with the main token of the blockchain. And that is a totally different way of securing an oracle. And so that's the first protocol. Provides prices secured by essentially the token of the network, secured by delegation of that token. So at the moment, the system has about 80 data providers. So that makes it quite decentralized. And it has a large amount of tokens being delegated to it, and we want to see more tokens.
I'm walking the bull, go, out for the.
Tranquility Base here. The Eagle has landed.
Welcome to the DeFi Standard, and this is Mickey B. Fresh.
Oracles are blockchain's connective tissue. They play a critical role in the emerging DeFi sector in order for DeFi applications to work and provide value to people and organizations around the world. This requires information from the real world. So like pricing data for derivatives. This is what oracles do. They serve as connective tissue for accessing, processing, and transmitting critical data. Oracles are essential for ensuring the integrity of data in the DeFi ecosystem.
The oracle problem is a really hard problem.
So what is the oracle problem in blockchain that has hindered the adoption of real-world applications and mass market utility of these applications? Up until this date, we have not seen a truly full-scale, decentralized, trustless oracle system that is economically incentivized to not lie. In a nutshell, the oracle problem refers to the conflict between security, authenticity, and trust in third-party oracles for the trustless execution of smart contracts. It is indeed evident that the oracle problem is hardly addressable from only a technical point of view. In the case of twin oracles, for example, a project like Chainlink is exceptionally effective against data tampering and oracle malfunction, but it can hardly fight distrust. This is what separates Flare from Chainlink, right here. And this is coming from an academic paper on this. And Flare is able to overcome this distrust because it provides an economic incentive to provide accurate data. And it incentivizes many participants to provide those price feeds and data. And then it involves all the users and token holders of the network and the native token value. So the token value isn't just used to reward the good price feeds, but it's used by the delegators to direct the vote power, which is the value of the token, to the most accurate of data providers. This is inherently, fundamentally, completely different than any other oracle we've seen to date. And it's at the blockchain layer. It's not at the Dapps layer. It's not a protocol with some random token. It's a L1 token that's a yield-bearing token with the distribution and governance rights and the ability to be used as collateral. So it's you're earning a massive, pristine, programmable layer one asset.
That makes it an incredibly decentralized price oracle. So there's 100 oracles for each price. There's 100 entities giving you each price. That is far more decentralized than any other system. The reason we can do that is because it's fundamental to the network. It's core to the network. It's built into the network. If you were trying to build that on top of another layer one, you would simply run into gas constraints that made it completely infeasible. And that's why we had to start a blockchain in order to make this work. So, the other solutions are pretty centralized. We've managed to create a truly decentralized solution because it's secured itself and it is part of the blockchain. And ultimately, the Flare time series Oracle nodes will become the validators of the network. So it's the first solution, and it's a fantastic price oracle.
And to have as decentralized system as possible. So, for instance, in our oracle system, if someone did try to put in a bad price, but the others are honest, they would be their price would be outside of the distribution that is captured. Essentially, we capture the center of the distribution, and their price would be in the tails of the distribution if they're putting in a false price to try and liquidate someone. So the oracle problem is a really hard problem. This is the riskiest part, or one of the riskiest parts of blockchain, right? Which is, how do you understand an external system without being centralized. So, you've had a lot of oracles that come along and ultimately they're centralized. If you really want a decentralized kind of future, then the protocol you're using to understand what has happened on an external system has to be meaningfully decentralized. And we have a lot of thoughts about, applying things like proof of stake to such a protocol. Like, then you can only ever be safe up to a certain amount of value.
To be precise, oracles in general do not insert information into the blockchain directly. Conversely, they gather and store data from the real world. That's where Flare differs. Because Flare, they absolutely do inject the data directly into the Flare time series oracle. When a smart contract concerning extrinsic data is executed, the code then calls for the right information from a trusted oracle. This is how a typical system works. To provide a decentralized oracle system is probably the most difficult thing that crypto has not been able to solve in the industry. Because to this date, we've seen protocols and different methods of using trusted compute. Proof of stake is a big one. Reputation systems. But what makes Flare's system inherently and fundamentally uniquely different that will allow it to be the base layer for data in blockchains? Because it has two core protocols embedded into the layer 1 blockchain, utilizing the native network's token and its value, as well as the underlying consensus and validators of the blockchain to secure it. And by having probabilistic data going through the FTSO system, and then you have deterministic data. It's not very well described when you read about oracles what the difference is there, but it's important for us to understand what that difference is, because you'll hear oracle problem, and those are two different types of data. There's cryptocurrency prices, for example. The FTSO has 80 different providers providing prices every 3 minutes for different time series. So there'll be the XRP USD price, the BTC USD price, and in the future, we'll see more indices, and we'll see indices priced to Flare. So FLR, XRP, we could see them priced to different decimal points and combined together to create one indice to one price. We could see temperature. We could see other types of time series in the future. But what is it that makes the FTSO system different than other Oracle networks like Chainlink? And I'm taking Chainlink as an example here because it's important to understand the fundamental difference, because that is the market leader to this date, and Flare is able to provide the economic incentive that's missing from all other Oracle systems, is that they put the native network token as the incentive to provide accurate price data. And they built in these pre-compiled smart contracts to run high computation to produce that median price feed. So they truncate off the top 25% and lowest 25%. So security-wise, the more Oracle's providing data feeds, all trying to get the best data in, and theoretically, they're supposed to provide what they feel is the best data. And the delegators, the users of the network who own the token's value, able to delegate vote power, but with that vote power, you have to have the token. So it's the value that's securing then who gets the most weighted vote power to provide those price feeds. And this inherently is in place of mining or proof of stake block rewards. Flare built the Oracle as the beating heart of the network because it's the hardest problem to solve. So let's put it with the thing that's most in demand. And Bitcoin prioritizes security, so that's why they proof of work mining. New Bitcoin is created to reward miners. And same with staking. So Flare put it there for data. So that's why there's such a competitiveness to get the best price. That's what you want. Chainlink's the opposite, and other networks. What they do is they'll put up stake, and sometimes they use some reputation, and then if they produce bad data, they get slashed. That's the opposite of Shelling Point. And Vitalik Buterin came out in 2014, and I believe he was the one to coin the phrase, the Oracle problem. And he said, to this date, Chainlink has not solved the Oracle problem, because the hardest thing to do is how do you economically incentivize an oracles not to lie? And when you add financial incentives in there, and DeFi, and different derivatives, and we're talking billions and millions online, that then could bring the oracles to act erratically and not on good behavior. But if they're incentivized to always produce the good data, they're going to always continue to produce that. And how else do you incentivize them? Most systems have always been centralized or trusted.
How does Flare's Stake Connector differ from other third-party Oracle services? Like we mentioned, Chainlink and some of the other ones, but maybe give us a little more meat on this.
So, again, it's decentralized. It operates with a large number of participants. It's embedded into the network, so it's part of the network. And this is where it gets its security from. So other Oracle services are, generally, broadly, they don't derive their security from being participants in a blockchain with value at risk. This is a really important factor. Like, essentially, they sit on top of a blockchain, and broadly, that is why they have had to have a centralized model, right? So you've had to basically trust oracles, and the reason you've had to trust oracles is because it's been too hard to engineer essentially a system where there's an economic reason for an oracle not to lie. This is why we've built Flare. We've built Flare to basically be a base layer for data, secured by the layer itself. And I think I said earlier that the most important thing about the stake connector is it's not secured by proof of stake. So even though to get into the stake connector, one will eventually have to put up some stake as being part of a validator, the security properties of the system does not rely on that. And the reason why that's important is because imagine if you have $100 million worth of stake, but you've been asked to confirm a transaction that has a value of $1 billion. The stake over here is nowhere near enough to secure the value here. And so whilst I won't go into it in too much depth here, the stake connector has a binary forking mechanism. This allows any minority set within the stake connector, so the validators of the network, to essentially, if the system becomes corrupt, to basically say the system is corrupt, we're not approving this new data. Here is a new version of Flare, which does not have the bad data embedded. This is the old version. This is the new version. And obviously, anyone that cares about essentially the data, about the applications that are leveraged from that data, about the value connected to that, they will migrate from the corrupt version to the version that does not have the bad data. So not only do we have the base staking security, we have an additional level of security that allows in a case where the system itself becomes undermined, malicious, it allows the system to essentially rectify itself without causing loss to the applications and the users that are using that system. We're most proud of that. because relative to other systems, whether you call it an oracle or whether you call it an interoperability protocol, everything else is secured just with money. And we think that security premise essentially is fundamentally flawed. The model from just money to money plus an ability to dissent and to create a clean network that does not have this bad data on it.
These protocols, and the value is in the protocols. Glenn Hutchins. And the idea of the Schelling point is to converge on the same price. So the idea of colluding to all get the same price, it's designed to make everybody want to get the same price. Because as long as they're all trying to get the same price, the system is operating correctly. Now, the reward distribution that's a mechanism design thing. And that's what will be added with the wider reward band. And also, this is just the beginning. This thing's at the heart of the network. The Flare token is built off of very special contracts that allow it to be cloned. So you could have distribute another token that's airdropped based on the exact distribution or supply that you have right now of your tokens because of vote power. So they've included this component of vote power. Chainlink doesn't have vote power. They just make a hierarchy. And I just want to reiterate the weakness of Chainlink, and it will always be a weakness, and it will never be solved because it can't be, is that they try to create this hierarchy system. And that is in the right direction. And they try to put trusted nodes at the tier at the top. There's very little transparency, which they could fix but don't. And who slashes them? And what if they collude with the tier 1? And this has gone, and this is the version 2. And they have the majority stake in the whole DeFi ecosystem by far. Now, Flare is trying to be the base layer. And ultimately, I could see a world where Chainlink would use the state connector to secure the top tier or the hierarchy, the top of the top, because you have a blockchain at the core, not secured by value. So if there's $2 billion going through it, or there's $100, it doesn't matter. The testers don't have any incentive to try to attack the network in the same way you would with proof of stake, because you're putting up stake and it's just based on that, and you could value more by attacking or colluding with bribers to provide inaccurate data feeds. And the other thing with Chainlink is it's spread very thin. It's got multiple different configurations on multiple different networks, and it's really expanded rapidly. So it's not that Chainlink is directly competing per se with Flare, but they kind of are. But it's what you can look to as this industry standard, and Flare is far superior in its design. And it's fact. It's not an opinion. It's not speculative. It's a fact. Because why? It's secured by the binary forking protocol. This protocol allows for the blockchain itself to actually be the determining factor of if this data is entered into the network or it's not. But it actually is injected into the blockchain. That is something Chainlink says is not even possible according to their documentation, because one, Avalanche is built on a completely different consensus that's nothing like any of the other Byzantine fault tolerance ones. It's nothing like Tendermint. It's nothing like proof of work. It's completely its own thing. So it throws the trilemmas out the window because it's able to accomplish all of them. And it's also, we could have different sets of attesters actually sending in data to the Flare network. Now, there's a third component here, and I just want to throw it in there just to cover all grounds, but it's not talked about as much. On the back end for these Dapps, because that's where this data is going to be integrated into. You won't see it on a public-facing, UI or anything, but it's going to be there, and where's it sourced from? And the Dapp needs to be able to verify that, or just like we have in zero-knowledge proofs, they got to verify or prove. You have to verify that these testers, put it through the Merkle tree and it was the right data. As long as they could cryptographically prove it, boop, They have the proof API, goes through it, shows that it went to the consensus of the attesters, and it was Merkle tree corrected, and the local attesters approved it, and it is actually injected like into the blockchain because Flare's network runs the EVM and contract and network layer basically together because it's built on Avalanche's C chain. This is what happens when you design a network on next generation infrastructure. And that is what Flare is built on. It is far superior to Ethereum, to Solana, any of those other ones, because, no, Solana is a little different, but Ethereum, your Binance Smart Chains, and your other types of networks that are similar, even XRPs. But XRP looks like it's going in that direction. Stay tuned. I'm still gathering information on how they're doing their side chains, but we're all going towards a multi-chain or constellation of flares and app chains world. This idea of a single chain, those days are over. They're long gone. And we're going to see networks of networks, subnets, supernets, side chains, constellation chains. And Flare, since it's built on Avalanche, but Avalanche is customizable. So don't get so caught up with AVAX and all those things. It's built to be customized and configured differently for different use cases. And Flare is the first to really like take the base, the code base, and make significant changes to adapt to their use case, which is data provisioning. The regular Avalanche does not focus on that. And their tokenomics is very different. So this is building on top of something that's new and then allowing to take advantage of its configurations. I'll go even a step further. That I'm going to do a video on this. Avalanche's big thing is that you could create all different types of virtual machines. There's 3 different chains in the primary network. They each have a different virtual machine by one set of validators. And you could create multiple custom virtual machines on multiple subnets. This is why Hugo has said consistently, well, a constellation of flares with different virtual machines. But Flare could add in the state connector. And that makes it even more powerful because now you can have these, instead of having a subnet messaging, they have state connector to state connector. So it's future-proof in ways that you can't imagine right now.
The second is the state connector. The state connector, again, uses the network structure to create a mechanism by which deterministic data can be essentially come to consensus to by the network nodes. And this is incredibly important. So that applies to things like blockchain state data, so what we call deterministic and immutable. And then things like what we, I guess, loosely term quasi-deterministic data. So this is an API from the internet that acts as a single source of truth. That single source of truth might be something like Twitter, might be something like Facebook, might be something like a game, essentially where if all participants go to that API, they get the same answer out. It's only quasi-deterministic because obviously someone's managing that database and can change the answer if they wish. So that's, but essentially the state connector allows you to get both types of data. Blockchain state data has a stronger security guarantee than API data because really our great innovation for the state connector is that there's a binary forking protocol for blockchain state data. Which means that essentially no majority of the nodes can essentially overrule the minority. And this is, I won't dig into it too much, but the binary forking protocol is what allows Flare to be somewhat invariant to the value of a transaction happening. And this is incredibly important.
So the blockchain Oracle problem is because of the fundamental limitation of smart contracts. It is that they cannot inherently interact with data and systems existing outside their native blockchain environment. Thus, any resource external to the blockchain is considered off-chain, while data already stored on the blockchain is considered on-chain. This kind of isolation is what allows blockchains to be secure. It's the foundation of properties like strong consensus, prevention of double spending, mitigation of network downtime. Securely interoperating with off-chain systems from a blockchain requires that there has to be some kind of oracle to bridge the two environments. So there's deterministic data, which is from another blockchain. So since public blockchains produce blocks or ledgers that close and they're publicly transparent, anyone can deterministically prove that this account at this time had 2.11 Bitcoin. And if it falls below that, it will auto-execute a contract on Flare that will liquidate a position. That's what's the power of what's possible here. Building these cross-chain applications. To this date, we have seen nothing like that. We've seen just basic oracles, and they're the weakest link in every system. And we've seen multiple failures from bridge hacks go through oracles. We've seen through Compound just using exchange APIs and trying to pull those in. APIs from exchanges are not, that's what causes these glitches and these prices to shoot up. That's all just glitches. And if you have millions, if not billions, on the line in collateral positions and different derivatives going forward with tokenization coming, you need to have the most secure, accurate, decentralized, and trustless. So the trusted solution is not even going to work when big institutions come in, because they're going to even see that even if you bring these assets on the blockchain, you still need to bring the data with them. And the data just doesn't come if it's especially happening off-chain. So being the base layer for data is a huge market. So Flare built two protocols and an underlying blockchain to secure the oracle problem and to provide probabilistic data and deterministic. So how do they do the deterministic? That's where they take the underlying security of the blockchain. That's where the emoji, the sun, that the symbol comes from, is from the binary forking protocol. So the attesters who run nodes on other networks or pull APIs from Twitter and the open internet or from other full history nodes, the default set come to consensus over multiple requests get batched that they have to pull from Bitcoin's blockchain, from XRP ledger, an account. And did this happen or not? Yes or no is the question. And that's all they have to bring back. They come to consensus. If 50% agree, then it goes to the local attesters. So what are the local attesters? It's the validators. So the underlying validators can be run by the attesters themselves in a separate machine, or they can run by, and they will be, by independent entities who are just validators or nodes. Because it has to run through a consensus. It's not just that the attesters are coming to up, 50% of them say it's good, so we're going to go on that. It's that the underlying blockchain validators are saying, hey, we're checking it, and it's got to go through Flare's consensus. So you're putting the most secure piece of software known to man, the machine, which is the blockchains. That is what is ultimately securing that data. It doesn't get more secure than that. And they built that binary forking protocol. That's what makes this powerful. Even if 70% of the attesters said, put in malicious, corrupt data, the system would still be able to overcome any type of attack or incident with corrupt data coming into the system, because it could have this fork where it branches. So it continues on like nothing's happened, but it has two branches. And as the system rectifies itself, and this happens all autonomously, everyone who cares about the applications, the value, and all the nodes on the network sees that this is the right data. There's no debate. It's a yes or no, and it's publicly transparent. That's for the deterministic. This goes for the web too. So if you could pull the Twitter API, you could see on this time, at that date, did this tweet happen, and what are the parameters? If they're there and they're visible to everybody, it's a yes or no question. So it could recover from an attack of 70%, 80%, and rectify itself. This is something inherently possible because Flare puts a blockchain at its core. So it does not use value to secure the deterministic data coming from other blockchains and from the internet. Now with the relayer, it combines both, and we'll talk about that shortly. So solving the Oracle problem is really important and one of the most critical things the industry needs to really gain mass adoption and see mass decentralized applications start to penetrate and proliferate throughout the broader financial economy. Most smart contracts use cases like DeFi require the knowledge of real-world data and events happening off-chain. Oracles expand the types of digital agreements that blockchains can support. This is done by offering a universal gateway to off-chain resources while still upholding the valuable security properties of blockchains. Most industries benefit from combining oracles and smart contracts, including asset prices for finance, weather information for insurance, randomness for gaming, IoT sensors for supply chain, identity verification for government, and much more. So another thing just thrown there is the randomness. So every time the FTO submit their prices, and they submit every 3 minutes another set of prices of those, of all the different, right now there's 12, 13 cryptocurrencies. There's going to be hundreds of different soon. And there might be different sets of FTSOs and different additional voters as well. So the system can grow massively. We're just at the very, very, very early days of it. And the relayer uses both systems. So how does this work? Because it uses the token's value now, right? The Flare token is securing that probabilistic data. Because how do you incentivize an oracle to not lie and provide accurate data? And especially when they know if they submit a price that's $2 less on an asset that's maybe $450, and they submit something that's $250, if it could liquidate a couple millions of dollars and they could profit from that, then they're incentivized to provide non-accurate data and act maliciously. It just creates that type of environment. So how do you solve for that and economically incentivize them? Well, you pay them fees, you put their stake up, but then they still have to be slashed. Flare, the price feeds coming into the network are secured by the economic incentive to earn native FLR. Instead of mining rewards, instead of block rewards, you earn FLR. And this comes out every 3.5 days, and the FTSOs are incentivized to try to get the most accurate of accurate price feeds. And being capped at 3.5%, 2.5%, they cannot sway the price feeds in either direction. And the lower 25% and the over 25% get truncated. So this narrows it down. The data has been spot on, the most accurate. It is the most decentralized Oracle system in all of blockchain. There's nothing that really even comes close. Because how do you get so many Oracle providers together and incentivize them to provide the price feeds? So then the FTSO system generates a median price for whatever the pairing is or index is. Let's say it's FLR USD. Just that's one that's on there right now. Eventually we'll see like FLR XRP. So what's the XRP price in FLR? Because that's what the asset system needs to manage a collateral position. So it gets this median price of FLR. And then these relayers, who will also be FTSOs, will just simply pull the median price feed. That's all they have to do. And now they relay that to a Dapp or other type of service or whatever it is, and the stake connector can be the one that can be the eye in the sky that can verify and auto/, if they produce data that is not accurate with what the median price was that they were supposed to relay. Now, they have no incentive to really lie, but they could. So having the stake connector there is a guarantee that they will be slashed. So they have to put up stake. So the delegators and themselves, and they will themselves be validators after the beta stage. So you'll be able to stake with the FTSO provider, who will be a validator. Now, here's where it gets really powerful. And if you haven't seen, check out my previous video on the data relayer, where I go more in depth on this. But it's important to understand how they both work together. So the stake connector can auto/ that FTSO that produces, that relays inaccurate data. And the Dapps can feel confident that they could use this data and have auto trigger contracts. That's what's missing from blockchain, is the ability to auto trigger to have true smart contracts. Right now, a lot of it is a manual call, which is dumb contracts. And they're still programmable, but there's no automation. And this would provide automation on all fronts. Now, with deterministic data, it's easier because it's yes or no. With probabilistic, it's much harder because one oracle, we've seen with Compound, for example, they were using Coinbase's API price feed. The API went down, and all of a sudden, things went haywire on Compound. People getting liquidated, and it was a disaster. So since then, the industry had woken up and said, we got to create something. But what have we seen built? Typically, it's Oracle, it's Dapps that produce their own Oracle systems, like MakerDAO, or like Uniswap. They create their own oracles based on their governance token. And then you have things like Chainlink, which is a Oracle protocol. It's not a blockchain. So Flare is the only layer 1 blockchain that is a data provisioning network that uses consensus and the security of the blockchain to secure the Oracle attestations from Web 2 and from other blockchains. And probabilistic data, it uses the blue chip premium asset that there is in crypto, layer 1's native token. So what miners earn, what proof of stake validators earn, this is what the FTSOs earn. So they created these 3 components, and then they involved the participation of the whole network to be able to delegate towards this, and then simultaneously be able to use that asset in collateral. So the participation rate will continue to increase, and that will decentralize the system more, because the total available market value for being the base layer for data when tokenization hits is mind-blowing. We can't even imagine what that looks like, because tokenization is what all these institutions, these asset managers, these banks are coming for. They're not coming to hodl crypto, and they're not coming to take your crypto. They're coming for tokenization and CBDCs and stablecoins. Now, public crypto is going to be in demand from their customers and enterprises, and as these public networks get robust and decentralized, and DeFi gets matured, that tokenization then has no choice but to get network effects. It's going to have to come into DeFi, as long as it comes in compliantly, and we see a rocket fuel added to DeFi. In addition, you bring data in, and it's just a nuclear explosion of development and a new financial system. So tokenization will supercharge DeFi, and data is coming first. So we need that before tokenization. Flare is trying to showcase what applications look like cross-chain. So instead of thinking of, I got to be on this network to use this application, that is going to change. That is going to change. That's what they're trying to break the developers from thinking like that. So since the data delivered by oracles to blockchains determines the outcome of smart contracts, it is critically important that the oracle mechanism is correct if the agreement is to execute exactly as expected. Check out these monstrous numbers that Chainlink commands of the market. Chainlink has become the preferred Oracle solution in the crypto market, feeding data into 170 plus projects that collectively support 15 billion in value as of Q4 2022. Chainlink's various chains and L2s. Link, the token, serves as the utility token for Chainlink Network, which acts as a trust-minimized middleware solution to the Oracle problem by providing reliable, tamper-proof inputs and outputs for complex smart contracts on any blockchain. In addition to being an important building block for DeFi, Link could connect blockchains to the traditional world of finance use cases, such as payment gateways, financial agreements, insurance, and among others. So we see the difference here. Now, they didn't go into it fully, but I'll just touch on it. Now, they're putting up stake, so you might be wondering, well, how do they get slashed if they provide a bad price feed? Or who determines that they provide a bad price feed? And this is where the whole Chainlink system does not have that trustlessness and that full decentralization and security underpinning it. Because what you ultimately have is then a tier 2 of trusted node operators who are considered trusted, but they're not known to the community of link holders of who they are, how much they're earning. It's all obscured. So there's a lot of trust involved, and it's been too hard to engineer for them into the blockchains. So they sit outside the blockchains, and they've done okay so far. As we've talked about, the Oracle problem is one of the most difficult problems to solve. You've heard Hugo say it. I explained it earlier. But why is it that Flare can integrate an Oracle system into the Flare network and other networks can't? Why are they built all on top of networks? Why does Chainlink explicitly say in their documentation that you can't input data from the outside world into a blockchain because it runs deterministically? This is because Flare Networks is purpose-built to solve this problem, and it's purpose-built on new architecture, on Avalanche's architecture and underlying code base that allows the C chain to operate separate from the consensus. So therefore, it could run these custom smart contracts, and it could also be able to utilize the native network's token value. So the layer 1 token, FLR, is used as a reward mechanism, and it's also used as a staking mechanism for the probabilistic data, right? Probabilistic, deterministic, and then the Web 2 data, which is very similar to deterministic. The token value, by putting the layer 1 token there, this allows for the probabilistic data, and it includes the participation of everyone in the network. So by putting this data provisioning at the heart of the network, the whole blockchain, it's the center. So you get everyone participating, and it creates a situation where everyone wants to come to the majority. So the idea of collusion here, and I've seen some people say that, oh, it's not decentralized. Absolutely wrong. This is absolutely decentralized. It's achieving what it's supposed to achieve. So we need to separate the rewarding of the distribution of the rewards from the data. And the reason why there's such an effort to get everyone to get to the same price or the majority is because the opposite is where the attack vectors come in. As soon as somebody has an incentive to bribe others' oracles to be able to profit by providing inaccurate price feeds, Flare has done everything in their design, from lowering the vote cap to 2.5%, by truncating off the 25% highest and lowest and creating a narrow reward band, which has just been increased slightly. But the focus was to over-engineer it to avoid a certain attack vector. And in the meantime, I think the idea of collusion has been misinterpreted by, I think, the broader community. So within the FTSOs, there's one conversation of that, but of the broader community to understand that this is the most decentralized. It's colluding to try to get the best price. So the intentions of the colluders are not to attack the system. Now, that's not 100% focused right now because it doesn't have all the pieces implemented. We're missing the F-asset voters. That's the whole other voters who have conflicting views. And the voters are voting because they have potential to earn rewards. Oracle systems, they're not blockchains. They have maybe a token to them, then they got to stake it, and then they maybe get rewards, and then they get slashed if they put bad behavior. Flare doesn't do that. Flare, the probabilistic data, this is for the Flare network. And this is a separate system from the state connector. Okay, so we got to separate these two. So I think it gets really confusing, and I think it's very difficult for, if you're first looking into this, or even if you have looked into oracles, to separate probabilistic data and deterministic. And I'm just going to repeat it again. Deterministic is when we're asking a question of a binary. It's a yes or no or 0 or 1. And there's definitive public proof, like a blockchain, right? Does this account have this much Bitcoin at this time? And did it change at this time? You could prove that and see it. That binary forking protocol is part of the state connector. And this is really what separates Chainlink from Flare. The probabilistic thing, there's no doubt Flare's system is designed better, but it's not designed to scale to the level immediately that Chainlink is. So it's not trying to compete with Chainlink in that way, but it's trying to build a foundation that could be the base layer. And to do that, it has to be phased approach. And another added on component here is they do tie the two Oracle systems together by having the FTSOs as also validators. Many of them, not all, will be validators. Then we get the staking component comes in. Now, that staking component is not going to have slashing, but it adds to the stake in the network. So they have a vested interest to provide always accurate data. And that's the thing here is you got to remember the attack vectors. As more value comes into crypto and DeFi gets bigger, any of these Oracle systems, they're going to be super weak links, and they're just going to crumble because it'll be so tempting for any Oracle just to deviate from the price because it could liquidate this one. And when we're talking billions on the line, a new financial system, you need to have the most robust security. And there is nothing more robust than a blockchain and its participants and its layer 1 token. But Flare does not use the layer 1's token to secure the state connector. Very important. This is how we have the guardians of the Flare network, guardians of the galaxy. Is the FTSOs, validators, and then a default set of attesters. But the local attesters, who are also the validators and also the default set, run separate software on the Flare network that pulls from a separate source. So say they were pulling from Bitcoin blockchain. They pull from not their own node. Maybe they pull from another full history node. And the local attesters do this too. So everyone's coming from a different source. If it's full history node, it's on the blockchain. So they're going beyond the default attesters by putting their own nodes on there. And then the software does everything. Now, when it's single source of truth, open APIs, that's like Twitter. There's many out there. As long as everyone has the same source where they could pull data from.
The thing that I think is exciting but also a challenge is we have to educate developers essentially about this new paradigm of what's available now. They have to change their in a way, we have to educate them so they can change their thinking. So they no longer think, oh, I need to build a product on one chain to do this thing. It's how do I build a substantially better product that can do stuff across multiple chains at the same time? And that's a much more interesting
concept.
It's a more interesting utility, but it's also not immediately accessible to most developers who are essentially cognizant of the existing model and are unaware of the capabilities of something like Flare.
So this idea, there's different ways to solve the Oracle problem for specific use cases. Flare is broadly trying to do it for a large subset of applications in the public blockchain sector. But you can't just do it with a simple protocol or a simple group of entities. You need multiple protocols, a blockchain, multiple sets of entities, and then the right mechanism design so that they're economically incentivized to behave in a way that's going to keep the system secure. And that's very difficult to do. And Vitalik, as the one who actually, he didn't coin it, but he was the one who came out and said it. Chainlink did not solve this. So stop saying you solved the Oracle problem. And I'm not saying that we're going to get an answer that, hey, the whole industry is going to know Flare solves the Oracle problem. It's not likely going to take place like that. But the app developers need to be educated that they can create applications that they don't have to implement on every chain. Like Aave, for example, has had to implement on Avalanche. Then they go implement on Polygon. Then they're here to build out an ecosystem for developers and mass adoption and having a huge, big impact. Something that's going to excite the Dapps developers. And as soon as they just showcased the NFT demo, so that NFT demo this past week showcased what is possible using just the state connector. And the Relayer is just one use case of utilizing both systems. So let's watch a video here of a short clip of Hugo talking about the demo and what it was capable of doing. Because this is something, a lot of those presentations, they're not directed at the community. They're here to build out an ecosystem for developers and mass adoption and having a huge, big impact. The community is going to have to level up and be able to now take advantage of this potential addressable market that's in the billions, if not more, from cross-chain DeFi. And the F-Asset system and Layer Cake are both inherently cross-chain collateral DeFi systems that are only possible because of the FTSO price feeds that could auto-execute the contracts cross-chain and the state connector that can then observe both chains at once and then auto-execute contracts on Flare. And I know I didn't bring it up much, but the FLR token is at the heart of all these use cases. So it's never forced to be there, but it's the most ideal asset for these protocols. And the value is in the protocols. Glenn Hutchins.
So today you saw an example of what we call a smart contract trigger. This is where a smart contract on Songbird or Flare is triggered by an action that happens elsewhere. In this case, the payment of Doge on the Doge chain and XRP on the XRP ledger. We bought NFTs on Songbird directly with XRP and with Doge. We did this in a trustless and decentralized manner. This is possible to do on Songbird today. There were quite a few steps. In reality, the bulk of this workflow would be integrated into a front-end product like an NFT marketplace or a wallet, such that the user only needs to do 1 or 2 transactions to buy an NFT on Flare with a token from any connected network. We look forward to helping developers build out around this functionality. We think it's really cool and very powerful. Thank you for joining today's demo, where we showed you a simple but powerful process native to Flare's core functionality. Thank you. Have a good day.
The community is going to have to level up and be able to now take advantage of this potential addressable market that's in the billions, if not more, from cross-chain DeFi. And the F-Asset system and Layer Cake are both inherently cross-chain collateral DeFi systems that are only possible because of the FTSO price feeds that could auto-execute the contracts cross-chain, and the stake connector that can then observe both chains at once and then auto-execute contracts on Flare. And I know I didn't bring it up much, but the FLR token is at the heart of all these use cases. So it's never forced to be there, but it's the most ideal asset for that is what is ultimately securing that data. It doesn't get more secure than that. And they built that binary forking protocol. That's what makes this powerful. And they're only able to do this because they used a blend of Avalanche's technologies on this C chain, pre-compiled these high compute contracts, and created this network of attesters. And this whole, then there's a verifying system on the back end. So Dapps need to cryptographically verify that the attesters and came to this Merkle tree and this cryptographic proof of them attesting to the data on Bitcoin's blockchain. This could be proven cryptographically and be simply done with a proof API. So it's all abstracted, but still, Flare had to build that in. That's part of a stack that will allow for Dapps to be cross-chain, and they could send data from one chain to another, messages from one chain to another. And then there's the idea of, bridging value and collateral systems and whatever else is possible. But Chainlink has fundamentally not been able to solve it. I point to them because they're the market leader. And the value is in the protocols. Glenn Hutchins